Hello guys, and welcome back to another video. So in this video what we'll be doing stoichiometric calculations. And stoichiometric calculations in simple terms are calculations that we'll be doing using ratios, mole ratios to be exact. And that means we will be ensuring firstly that our equations are balanced. As you can see, this one here, it's a balanced equation. And yeah, we'll use those coefficients of the balanced equations to do our calculations. Let's see how this works. Okay, so here our statement reads that aluminum burns in chlorine according to the following balanced reaction equation. So this is our equation, and like I've already said guys, that when doing these type of calculations you need to ensure that your equations are balanced. All right, and then the instruction is that we calculate the volume at STP of chlorine gas, or rather Cl2, required to react completely with 30 grams of aluminium metal according to the equation given. What are we looking for here guys? We are looking for the volume. We are looking for the volume of what? Of chlorine gas. Okay, that's what we are looking for. Let me just highlight. We are looking for the volume of gas, but this has to this is basically happening at STP. And when you do these calculations guys, you need to write the information that you are provided. So in terms of this problem, we are given the mass of aluminium. Let me write it like this. We are given the mass of aluminium. As you can see, the mass of aluminium is what? It's this 30 grams here. That's the mass of aluminium. So I'm just gonna write it here. When I advise, in fact, that when you do these calculations, you write the information that you are given. Then we are also asked to find what? We need to also write what we are looking for. We are asked to find the volume of the chlorine gas. That's what we are looking for. Why am I putting these things down? It's because these things help me to know which formula I'm going to use. But another thing about the volume that I'm looking for is that it's at STP. Calculate the volume at STP of Cl2. Which formula has STP? Or rather, what's the meaning of STP? The meaning of STP is standard temperature and pressure. And under these conditions, according to Avogadro's law, we know that the gases are gonna actually have the same, or rather occupy the same volume under these conditions. And that means we have to make use of this formula, V over Vm, and we know that this is our molar volume, which is a constant of 22,4. Yeah, the unit I'm not gonna write because this is a constant that's given to you on the data sheet. And yeah, because of that, I'm just gonna give you the value. Now let's get into solving this problem. Okay, the first thing that we're gonna do here guys is to convert the mass of the aluminum into the number of moles, because we need to figure out the number of moles of chlorine using the number of moles of aluminium. And how are we going to find the number of moles of chlorine? We will be making use of ratios. Remember, I said stoichiometric calculations are about us using ratios. Let me get into it. So the first thing that we do is to convert this mass into the number of moles. So we are going to look for the number of moles of aluminium given that we have its mass. So that's our step number one. We find the number of moles of aluminium, and the formula we use obviously is mass over molar mass. Then when we substitute, our mass for aluminium is what? 30, and the molar mass, the big M obviously stands for molar mass. What's the molar mass? The molar mass of aluminium is 27. Where am I getting this number? I'm getting this number from my periodic table. So when you do these type of calculations, it's important for you to have your periodic table next to you. And yeah, the molar mass will be that number at the bottom of the element symbol, okay, and it's normally the bigger number there. So we will have 30 over 27, and let's see what our answer is going to be. Okay, when I say 30 divided by 27, the value I'm getting is 1,11 moles. I've obviously rounded off this to 2 decimal places. Now, after we find these number of moles, guys, we are now going to use these number of moles to find what? The number of moles of chlorine, but using gases. But why are we looking for the number of moles of chlorine? It's because the volume that we have to find of chlorine requires us to have the number of moles and the molar volume. So with the molar volume, we are already sorted. We know that the molar volume, which is this Vm, is equal to 22,4. But the number of moles of chlorine is unknown. And guys, it's impossible for us to find the number of moles of chlorine using this formula. We cannot use this formula because we do not know the mass of chlorine. Do you get it, guys? We do not know the mass of chlorine. That's why we have to use our mole ratios to find the number of moles of chlorine. I hope, guys, that is making sense. So that's going to be our step number 2. The step number 2 is to use the number of moles of aluminum to find the number of moles of chlorine. Why are we doing that? Because we cannot use this formula to find the number of moles of chlorine in terms of this problem. So let's proceed then. What I'm going to do, guys, is to write the substances that I'm dealing with based, or rather in terms of ratios. And when I write my substances, I'm writing the substance that has the information and the substance that doesn't have the information. At the moment, I have aluminum. And in terms of aluminum, I know the number of moles of aluminum. So I'll say aluminum is to chlorine. I'm writing the substances that I'm dealing with here. Aluminum that has my information, and chlorine that doesn't have the information because I'm looking for its information. After this step, we are now going to move on to what? To our step number, or rather second part of step number 2, which is to write the coefficients of these two substances. The coefficients, guys, are the numbers that are next to my substances, right? These numbers here, the 2 and the 3. So what is next to aluminum is 2. So I'm going to write that number here as a ratio. So I'll say 2 is 2. What's the number standing next to chlorine? It's 3. So I'm saying 2 is to 3. After writing the coefficients, guys, which I call my mole ratios, I am going to write the number of moles of these two substances. Are we clear? What are the number of moles of aluminum? I found them here, and they are 1,11 is 2. Do I know the number of moles of chlorine? The answer is no, I do not. So I'm just going to write N there. And then what I'm going to do now is to calculate the number of moles by doing what? Cross multiplying. So I'll say 2 multiplied by N, and this is going to give me 2N is equal to, and then I'll say 1,11 multiplied by 3, and this is going to give me 3,33. Remember what I'm doing here. I'm trying to solve for N. So I'll divide by 2 on both sides. And this means my N, let me see. If I say 3,33 divided by 2, the answer I'm getting is 1,665. But I'm going to round off to 2 decimal places. So that means my answer will be 1,67 moles. Once I have these number of moles for chlorine, guys, my third step will now to finally find the volume of chlorine. So step number 3 will be for us to finally find the volume of chlorine using the formula N is equal to V over Vm. Why am I using this formula? Because my statement said that I must calculate the volume at STP. So when you see STP, it means your reaction is taking place under standard temperature and pressure. That's why you have to use this volume, whereby your gases have the same molar volume or occupy the same volume. So now I'm looking for the volume of chlorine, right? What is the number of moles of chlorine? It's these ones that I just found using ratios 1,67 is equal to the volume of chlorine is unknown. Maybe let me just say Cl2 there, just for you to be aware that we are looking for the volume of chlorine. What is Vm? The molar volume, it's 22,4. And then I'm just gonna let me multiply by 22,4 on both sides. These are going to cancel, or you can just cross multiply, guys. That's also another option. So when I say 1,67 multiplied by 22,4, the answer I'm getting is 37,20, or yeah, I think that's what I'm getting. Okay, I made a mistake, guys. So when I say 22,4 multiplied by 1,67, the answer I'm getting is 37,408. But if I round it off, I'm gonna get an answer of 37,41. So therefore, the volume of chlorine will be equal to 37,41 dm cubed. And that's how you basically deal with this calculation. If you didn't understand this video, guys, my advice is that you rewind it, play it again, or watch the other videos that I'll be uploading. See you on the next one. Bye bye.